You're very welcome to the Emerging Energy Technologies webinar this afternoon. My name is Orla Burke. I am a committee member on the Electrical Division in Engineers Ireland. So delighted to welcome you all on behalf of the Electrical Division. Just some housekeeping, please put any of your questions in the Q&A box at the bottom of your screen and we'll address them at the end of the presentation today. And the presentation will be made available in the coming days. So today's webinar should be extremely interesting. It's focusing on ESB's Emerging Technology Insights Report, and that examines a wide range of emerging energy technologies and a key focus on how they can assist ESB's net zero strategy. And I'm delighted to welcome our two presenters, John and Thomas. So John is the Emerging Technology and R&D Manager in ESB, and he's responsible for leading ESB's group strategy for the adoption and commercialization of emerging energy technologies to meet the evolving needs of customers and to grow new business in support of ESB's net zero by 2040 strategy. We're also joined today by Thomas. He's an energy innovation specialist with the Emerging Technologies and R&D group in ESB. He's an energy innovation specialist who holds a master's degree in mechanical engineering from the University de Lorraine. In his current role, he is screening and promoting emerging technologies to support the organization's decarbonisation targets. And the range of technologies vary from vehicle to grid chargers to wave energy. And he was instrumental in successfully securing a €39 million grant funding for the Saoirse Wave project from the EU Innovation Fund. And that's a 5 megawatt breakthrough wave energy development to be deployed off the coast of County Clare. So without further ado, I'll pass you over to John and Thomas, and thank you everyone for joining once again.
That's great. Thank you very much, Orla, for the introduction. And look, we're both delighted to be here this afternoon. So look, my name is John. My colleague here is Thomas, and we're going to spend the next few minutes just talking you through our approach to emerging technology. We have an annual insights report. We'll share some of the key findings from that today, along with some of the industry trends that we're seeing. We have a number of pilots and demonstration projects that we're developing to try and accelerate the development of these low carbon new technologies. So we'll talk our way through some of those and share some of the case studies that we're developing. And then I think Ed is going to chair a Q&A session at the end. So if you do have any questions for us as we go through the presentation, we'll be delighted to discuss at the end of the webinar. And if you'd like to drop the questions into the chat, I think Ed will moderate those as we go through the session. So without further ado, I'd like to introduce the Emerging Technologies team. We're a small team within ESB. We have about 5 engineers in the group. We work in the innovation team, but we also collaborate across the industry. And we spend a lot of time talking with our colleagues, both in research labs and in industry, to try and understand what are those key emerging technologies that we need to develop and accelerate to enable a net zero energy system. Here in ESB, we've committed to transition our own systems to net zero before 2040. And we recognize there's a whole load of new emerging technologies that we're going to need to develop and deploy at pace to be able to transition our current energy system to a net zero one. So to do that, we work with a lot of very different people. So we work with research labs such as EPRI or NREL in the States. We have a research program underway with universities like UCD or the MARI team down in UCC. We also work with Queen's, University of Galway, Maynooth, Trinity College. We also work with specialist teams. So for example, we work with the Offshore Wind Centre of Doctoral Training in Strathclyde University, or there's a brilliant research team who have been working on hydrogen for the last 30 years in Loughborough University. So we work with that team there. We also have internal innovation teams within each of our business units. So those teams are working on the front line with how do we deploy these new technologies. So we tend to work hand in glove with those teams. We also reach out to our peers. So where we have utilities who are perhaps more advanced than us. So, for example, someone like Origin Energy in Australia has been working on how do we use flexibility to increase the amount of solar energy that they can use. We tend to reach out to people like Origin, and they tend to collaborate very openly with us on how they're starting to drive innovation across their energy system. And we take the learnings from what other utilities are doing in other countries, and we try and adopt those here in Ireland as well. We work with state bodies like SEAI, with other corporate research teams. We have a number of startup accelerator programs that we work with. A great example of that is the Free Electrons program. It's a collaboration amongst 10 utilities around the world, and we collaborate together to develop a call. It's an annual call for startups, and we get about 700 to 1,000 applicants a year. And the startups have a whole range of new and exciting innovations in the energy industry. What we try and do is shortlist the startups that we work with down to about 60 or 70 at the start of the program. And then we go through a trial and prototype program with them. It's also a great way for the startups to meet the utilities and get some insights and feedback from the utilities on how we're going to use their technologies in our businesses. And then we try and run, here in ESB, we run kind of 6 to 9 trials per year. And the other utilities who are part of the programs also run similar trials, and we share the lessons learned across the utilities. So it's a great way for us to go and meet real innovators and startups and work with them in a meaningful way each year. We also partner with a lot of the EU research programs like Horizon. We have a number of Horizon programs underway, and we also utilize funds like the EU Innovation Fund, which is it's a great fund to be part of. So we tend to talk and work with everybody, and certainly in terms of the scale and the magnitude of the transition that we're working our way through, I think it's very much an industry transition. So we do need to have a very open way of communicating. So if we just move on. So one way we communicate with the industry is through the Emerging Technology Insights Report. Maybe Thomas, you might want to say a few words about that.
Yeah, thank you, John, and good afternoon, everyone. So every year with the team, we're publishing our Emerging Technology Insights reports, where we're presenting the most recent developments and the outlooks for a range of between 25 and 30 different emerging technologies. And they cover the whole energy system, from generation, distribution, demand side. And what we're trying to achieve with that is to inform ESB with what emerging technology might help us to achieve our targets of achieving net zero by 2040. And also we are publishing this report. It's available on the ESB website. And the intention is also to promote the dialogue from the Irish energy community, and to have, I suppose, to get feedbacks from this community back to us, to always improve our views and our understanding of those emerging technologies. So it's a report that we're publishing every year, and so that's why this, I suppose, the feedback is very important, just to in order to make it better and more accurate year on year. So yeah, next slide, John, please. So we're using 2 metrics to order our range of emerging technologies. The first one on the left-hand side is the technology readiness level, or TRL. So it's a metric that's used, that's widely used in the technology development industry, and it was actually set up by NASA to qualify their technology before launching them in space. So it's a scale that goes from 1 to 9. So 1 is it's a concept or an idea that's on the paper, and then 9, it's a fully commercial technology. And typically with the team, we're engaging with technologies which have achieved the TRL 6. So TRL 6 means that it has been a prototype, not necessarily full scale, has been tested in a relevant environment. So just that we're engaging with those technologies that are relatively mature. So we're taking those technologies, we're mapping them out on this radar. You can see there on the right-hand side, which shows the different TRL and how we also splitting those technologies from generation, grid, etc., etc. And we're also using a commercial readiness level, and this is to assess, or this is used, I suppose, to assess how close to commercialization those technologies are. It's not necessarily because a technology is achieved TRL9 that is already commercial. And this commercial readiness level is really taken from an Irish perspective. So here, for instance, on the radar, we have biomethane, which is TRL9, and it's widely used in Europe. But for instance, for this technology in Ireland, we're still at the early stage of commercialization. So that's why it's highlighted as yellow there. So between 1 and 5 years away from commercialization. So that's it for this radar. Thanks, John. Next slide, and I think it's back to you.
Okay, great. Thanks, Thomas. So some of the trends we've seen in the industry over the last 12 to 18 months. Maybe if I start in the top left-hand corner of the chart, we've seen the price of PV collapse by over 90% over the last 10 years. I guess one of the other trends we've seen, though, which has caught us a little bit by surprise, is the fact that the cost of storage has also decreased significantly. So over the last 15 years, we've seen the price of lithium-ion storage come down by about 90%. And the IEA are projecting a further decrease by about 40% by 2030. So that's really interesting in that we are starting to be able to use storage to do things that we couldn't do 5 years ago because the costs have become so much more competitive. We've also seen the demand growth driven by generative AI. So it's a relatively new phenomenon, and there was an interesting stat given out last month where the amount of energy required to do a search using ChatGPT is 10 times that by doing the same search using traditional Google. So we've seen steady growth through data centers here in Ireland over the last 10 years, and there's a forecast from EirGrid to say that will continue to grow. However, the change in the industry from traditional computing to using Gen AI is quite scary in some cases, driven by that large increase in electricity demand needed by generative AI engines. So certainly one to watch. Also, we've seen some great progress in the floating offshore wind markets. Last year, we saw an auction in Brittany. So the French government have a very strong program to develop floating offshore wind. They ran an auction in Brittany for about 270 megawatts of floating offshore wind. And the winning price came in at 87 euros or 86 euros a megawatt, which was much lower than the market had expected. When we unpicked the bids, we were a little bit surprised to see that the size of the turbine that the winner had put forward was 24 megawatts, which is a relatively large system. However, I think it does show the confidence the industry has in developing floating offshore wind over the next 5 to 10 years. We've also seen the launch of the National Biomethane Strategy last year. So it's a part of the energy system in Ireland, which is probably been underdeveloped when we look at our relative performance compared to our European counterparts. So we are looking forward to seeing how the RHO, so the Renewable Heat Obligation, is developed through this year, because it is a part of the decarbonisation story, which I think will have a large impact here in Ireland. Just two other quick trends to mention. Last year, we saw hydrogen auctions in the UK and in Europe. Both auctions were very well oversubscribed. UK government has taken a very different approach to the EU in how to support hydrogen. So the UK are they're going to, I guess, support the difference between the market cost of hydrogen and the market cost of natural gas. So the support scheme in the UK cleared at about 11 euros per kilo of hydrogen. The EU has taken a different approach, and they're providing a top-up support just to make the market whole. So when they ran the auction, it was generally companies in Norway and in Spain and Portugal who won the process. And the top-up support given by the EU is around about 40 to 50 cents a kilowatt, so, or a kilowatt hour. So it's a very different outcome. So we're watching with great interest to see how the markets develop, both in the EU and in the UK, to see the impact of the different approaches in support. And then just finally, there's been a lot of talk around small modular reactors. I think the story around NuScale back in 2023 was a little bit disappointing, where they had a number of really good projects being developed, but unfortunately the price continued to rise as the projects were developed, and it got to a point where the price was far higher than the market could take. So some of those projects fell away. What we've seen through 2024, though, is the rise again of small modular reactors and the industry interest in developing this form of new technology. We are seeing a number of reactors in development in China at the moment. We are also seeing some projects being developed in the US as well. So it's part of the market we're watching with great interest. So maybe looking forward a little bit from an Irish perspective, the technologies we think will have an impact here over the next number of years. So when we say medium term, it's generally 3 to 5 years. We do expect biomethane, the industry to start to take off at pace here in Ireland. We think there is a lot of new technologies in medium duration storage, which are really, really interesting. So both flow batteries, and then on the bottom right-hand corner, there is a picture of a CO2 battery system. So we think we'll start to see the introduction of medium duration storage in Ireland in the medium term. Heat pumps are getting better and better, and we're seeing very large heat pumps capable of producing very high temperature heat starting to come to market as well. So we think that will have a larger and larger impact here in Ireland. The picture in the top right-hand corner is a picture from the Viking interconnector in the UK. So this is the longest HVDC interconnector in the world at the moment, which is connecting the UK and Denmark. We're seeing a number of these very, very large projects starting to be developed. There's one called X-Links, which is planning to connect the UK with Morocco. So it's a 3.6 gigawatts interconnector, and the plan is to build lots and lots of PV and batteries and wind in Morocco, and to directly connect that to the UK, which would be a great way to decarbonize cities like London. We're seeing other projects in Australia. There's a great project there called a Sun Cable, which is looking to connect the Northern Territories in Australia with Singapore. So that project, the cable is going to be about 4,200 kilometers long and connect about 20 gigawatts of PV in the Northern Territories to Singapore. So absolutely brilliant projects of huge scale, but it's a great way to start to connect centers which are hard to decarbonize, like London and Singapore, with areas which have a high potential for renewable energy, like Morocco or the Northern Territories in Australia. Floating offshore wind, we're seeing develop at pace in countries, and it's great to see countries like France take such a bold ambition with developing floating offshore wind. V2X, Thomas is going to talk a little bit more about this. We think there's a great opportunity to develop flexibility across the grid by using the potential of the electric batteries in electric cars. The large dome in the bottom panel is a CO2 battery. The large white cylinder shape is the low pressure side of the system, and that's filled with CO2. It's a closed system. And when it's windy, the CO2 is pumped from the low pressure side and compressed into a high pressure container. And then when it's not windy, that CO2 is then released through a turbine to generate electricity back into the low pressure side. And the CO2 goes back and forth in a closed way. And there's just the final kind of impactful technology we see developing is hybrid grid connections, whereby we can start to couple multiple technologies, multiple renewable technologies, along with storage at grid connections. So rather than just having a wind farm or a PV farm, we would have a hybrid connection, and we'd be able to do some balancing behind the grid connection. So yeah, so there's absolutely lots and lots going on in the short and in the medium terms in terms of new technologies. And maybe I'll hand back to Thomas.
Thanks, John. So in the next few slides, we're going to focus on some spotlights and case study that we're working on with the team. And the first one there is about long duration energy storage. So we see long duration energy storage as playing a key role in the future energy system with lots of intermittent renewables. We need a way to balance the grid between generation and demand, and definitely LDES will have a key piece to play in this system. So when we say long duration, it's anything that is more than 8 hours worth of storage. So lithium ion typically can cover a storage from 2 and then 2 hours at the start, and now with the cost of battery storage system coming down, it can go up to 6 and even 8 hours. So anything more than 8 hours is something that we look into when we talk about LDES. So we identify that there are loads of different concepts and varieties of technologies when it comes to LDES, and we wanted to increase our understanding and capability when assessing those technologies and find a systematic approach to rank them and to identify which one is leading, which one is the most relevant for us. So we started last year a ranking study on LDES in partnership with EPRI. So EPRI is international kind of electricity industry body. And basically we took all the concepts of LDES that we notified, and there was 120 of them. And we mark each of those concepts against metrics and against metrics that we identified as relevant for LDES systems. And from that exercise, with that systematic approach, with that systematic ranking, we identified 5 leading technologies in each of the big categories of LDES. So those big categories, they're thermal storage, mechanical storage, and chemical storage. And with those top 5, we went into another layer of assessments and went to a more detailed technology due diligence. And from that exercise, we identified 3 leading technologies, which are called out there in the slides. The first one is ion air battery, which enables energy storage up to 100 hours. We have a mechanical storage, the one that John talked about there in the previous slides, which is compressed CO2 battery, and that enables storage up to 10 hours. And we have also another chemical energy storage, vanadium flow battery, which enables storage from 8 to 12 hours. So with the 3 identified leading technologies, we are now going a step further, where we're looking at demonstration and pilot project feasibility, and going through site selections and looking at the planning constraints and the grid constraints those need to be operating. So that's really our work stream on LDES. So next slide, John, please. So the next one is about storage again, and unlike the previous one, which was about large grid scale battery, this one is about small batteries which are in our EVs, and it's what we call smart EV charging, which extends to bidirectional charging. And that graph you can see on the right hand side there was published by Bloomberg last year, and the highlights there is I suppose the Bloomberg projection of the energy system in 2050, which shows that the flexibility that is provided by smart EV charging is equivalent to the flexibility provided by grid scale battery. So it shows how key smart EV charging and battery charging will become in our future energy system. And in the team, we need and we want to build up our understanding and capabilities on that to anticipate and to prepare to be prepared when those technologies come online. So we are working on different pilots across the business. So our colleagues in ESB networks, for instance, are running flexible charging pilots, and for them it's to understand the impacts that those technologies have on the network, but also what kind of flexibility markets they can design to accommodate those new technology and to enable flexibility from EV charging. And also our colleagues in Electric Ireland are working on smart EV, on smart charging, to understand what kind of innovative services or product they can offer to customers. So it's really across domains, and I suppose from our side it's more around the technology and what's the gap between smart charging, which is really ready from a technology perspective. It's already ready. It's really something that's possible, and all the way to bidirectional charging, which is more challenging with technology. I suppose there is no convergence towards one bidirectional system. There are many possible between the different charging systems, whether it's going to be AC or DC. So we're looking at trialing and piloting those different methodology, so that we can enable this future energy system where a large portion of flexibility is coming from the way we charge our EV. Yep, that's it for EV. Thanks, John. Next slide. So the next one is about floating offshore wind. So we are developing floating offshore wind projects in ESB, and this particular one there, called Malin Sea Wind, is a 100 megawatt floating offshore wind farm. So we were successful in Crown Estate Scotland leasing round, which was called the INTOG leasing round. So there was a section on innovation and a section on targeted oil and gas, where the idea was to develop the synergies between the oil and gas sector and the floating offshore wind sector. And so we were successful in that listing round. So we are at the development stage of this project, with surveying ongoing between 2024 and 2025. We have stakeholder engagement ongoing, and we are aiming to have the wind farm operational by 2031. So we're supporting the delivery team on that project on the innovative section, which is very much related to a mooring load reduction device that John will go into further details in the next slide. But yes, this is, I suppose, show that we're working on innovative floating offshore projects in ESB. And the next slide, John, please. So this other project is also an offshore project, and it's called the Saoirse Wave Energy Project. So what is it? It's a 4.9 megawatts wave array pilot that is to be deployed off the coast of County Clare. And we are working on this innovative project to establish or to understand more the relevance of wave energy, the benefits that wave energy can bring onto the grid. So the anticipation is that the wave energy profile is complementary to other renewables such as wind and solar, with I suppose the typical wave profile will like the wind profile. So there is benefit there in terms of grid balancing. And maybe the other point is that Ireland has a huge wave potential of its west coast. So there's a real potential there. And what we're looking at achieving with this project is to understand the scale of this potential, how feasible it is. And so we're working on developing this pilot of 14 wave devices. So we applied to the Innovation Fund, the EU Innovation Fund, back in 2023, and we were successful in securing a 39.5 million euro grant agreement with CINEA, who are the EU granting authority. And we are now in the second year of the grant agreement, and still in the development phase of this project. So we're progressing the engineering design, the technology due diligence. So we're working closely with our preferred technology supplier, Coop Power Ocean. So you can see their device, their prototype there, deployed off the coast of Portugal, so where they're running their full-scale testing at the moment. So we are having a strong, I suppose, due diligence ongoing with them at the moment. And we're also progressing the permitting and consenting of the project. And we're at the moment we are working on our licenses for site investigation. So that is in a nutshell for the Saoirse Wave project. And I think the next slide is back to you, John.
Back to me. I love this project, by the way. I think Ireland has such a great potential for wave energy that it's we need to be pushing these ones. Well, just move on. Yeah, and just to say, some of the innovations that we work with very much in partnership with other companies. So this is a great case study of a collaboration we've been working with Dublin Offshore for a number of years, and it's on an innovative load reduction device. So the concept is that with these enormous floating wave or floating wind platforms, they need to be anchored to the seabed, and the size of the chains and cables required for anchoring can be considerably reduced by using these devices. It's effectively a damper, and we expect to be able to deploy much smaller cables, and actually it should also reduce the stresses and strains both on the anchors, the cables, and the platforms themselves. So it's one of a number of innovations that we're working with the supply chain on to try and make the transition to offshore as smooth as possible. Just one of the other projects we're working on, we have a pilot electrolyzer which is being deployed in our Ahada plant down in Cork this year. It's a 1 megawatt electrolyzer which will take renewable electricity and generate hydrogen from it. But this is slightly different. This is a hydrogen fuel cell. So we have 2 fuel cells which we have built last year. They have batteries included with them and can produce 250 kilowatts peak. So we're using these as a direct replacement for diesel generators, and we've done a number of trials with customers over the last 6 months. So these, I don't know if you've seen the hydrogen fuel cell on tour. If not, it'll be coming to a customer near you soon. And we're looking to displace diesel generators as a proof of concept. So for example, we recently deployed one of these in a Microsoft data center. We also powered the Irish Open using one of these hydrogen fuel cells. And they very much do what they say on the tin. You just provide the hydrogen and the fuel cell provides the electricity on site. I think the next deployment for one of these fuel cells is to power a film crew. They have a film production which is 6 weeks long down in Wicklow, and they were looking for a way to generate electricity on site. So we're going to continue to deploy these fuel cells through the year, really to try and give the Irish energy community confidence that hydrogen is a viable way to provide renewable electricity. And look, after kind of working our way through the Emerging Tech Insights report this year, and running the pilots and running the trials and working with our industry partners, I guess our main conclusion, and it'd be great to get the discussion going in terms of the feedback from this webinar, is that new energy storage technologies are really the key to a renewable transition. So we're going to continue working on piloting and doing some demonstration sites on some of the new innovative technologies that we're seeing, because we think that's probably one of the largest areas that we need to focus in on in the medium term. So just before we break and get into the Q&A session, just like to thank everybody for your time on this webinar. The Emerging Tech Insights report is available on our website. So if you want to download it, there's about 30 technologies profiled there. There's some cost information. We've got some views as to where we think the technologies are going, and we use that to develop our technology roadmaps. If you have technologies that you think we would be interested in, we'd love to hear from you. And we do like to work right across the energy industry wherever possible.